Welcome back to the Energy Sovereignty Project and our studio once again. This is going to be a short video as a bit of a primer for what we're about to see in Battery Investment Day. And I'm doing this video kind of in an ad hoc way. Some of you are familiar with my current situation. I'm actually not able to get here to the studio for any longer than a couple hours at a time, and so that makes the production of these videos that you're used to really pretty much impossible. So what you're going to see here is basically what I was able to throw together for you guys, just so that you'd have a bit of an understanding going into Battery Investment Day about what they're going to be revealing. And not only that, but why it matters, because that's obviously what you're all tuned in here for. And for those that are new to this channel and to the Energy Sovereignty Project, the reason some idiot here in a plaid shirt is just kind of flapping his gums about all of this is that for nearly 20 years I was an industrial process engineer, not for battery technology, but for a major medical device manufacturer, designing the exact same kinds of equipment for scalable manufacturing that we're going to be talking about today, and that they're going to wind up being revealing in Battery Investor Day. And so because of that, and my interest in all things solar and electric vehicles, all things that are going to actually wind up propelling us into this reusable or sustainable future, folks have very kindly logged on to the site, and we've had marvelous conversations about what all this technology is going to mean moving forward. And so with that, let's go ahead and discuss a little bit about what brought us to this point really quick, and then we can move on to what you can expect for Battery Investor Day. Now again, for those that are just joining us, I would highly suggest that you take a look at some of the earlier videos, especially this one. And in this one here, we laid out the timeline for development of some of these new battery technologies. And again, a lot of it on the premise that I think that what they've been marching towards is a solid state battery. Now, like all solutions, the actual solution that they announce tomorrow on Battery Investor Day, they are going to wind up probably talking about hybrids, and where these batteries, you're not really going to be able to draw a firm distinction between a solid state battery and the architecture of the currently existing lithium ion batteries, where they use a paste electrolyte to activate the battery. So look for that. But again, in this video that I showed up here, I'll have the link in the description. What I did was I reviewed what was happening at Tesla's Cato Road facility. Back in 2014, 2015, they started to do a build out of a unit just down the street from the Tesla automotive factory that many speculated was just some kind of an annex and all that. So I actually wound up taking a trip out there to take a look at what that building might be. And in retrospect, as we started to do this video on how long could they have been working on this, it dawned on me that what this facility is, and now we know that that's true, is a development, a skunk works, if you will, a research lab that will allow them to do, again, just what we did with our company, Invisalign, Align Technology, and that was to build scaled versions of your manufacturing facility, all of the components, stem to stern. We had an enormous lab, just like they do in that Cato Road facility. And in this lab, then that allowed us to try a variety of different methods to be able to then create the manufacturing equipment to make our product and to test it, see that it's scalable, test the product that comes out for consistency, and then look at how it integrates into everything that we're currently doing. And so again, that's what that Cato Road facility was up to. And again, they're going to take you on a tour of that facility. I'm very excited to be able to see what they're going to show about what happens on the inside of that facility. I think it's going to be really neat. Well, so also back in some of these videos, there was a lot of FUD, fear, uncertainty, and doubt being tossed about Panasonic's relationship with Tesla, and Panasonic was going to pull out and all that. And back in that first video, I tried to explain to folks how these contracts actually work, and that Panasonic, Tesla, CATL, any company that's going to be working with Tesla, they're going to wind up creating these win-win contracts. It doesn't do anybody any good to wind up having these contractual obligations that they then call the other company on, that then will wind up destroying the other company. It makes absolutely no sense to do that. It makes sense to cooperate with them, and in the case of Tesla and Panasonic and CATL and some of these other battery manufacturers, what they're going to wind up doing is they're going to wind up licensing their technology to allow these other battery manufacturers to make better, cheaper batteries faster. That's what this is all about. That's what Battery Investor Day is going to be all about. So, with all my blathering now, what the hell are they doing? Well, what they're doing is they're optimizing the battery cell architecture. Now, one of the things that CATL has a lot of core competence in is making that prismatic cell, those flat pouch type batteries. And we may see them talk a little bit about that, but we know now from some of the things that have been leaked to Electrek and some of the others that the format of their new battery is roughly this. This is one of those mini soda cans, and so this is just for kind of a quick reference. This isn't an exact size, so don't try and call me on that too much. This is just to show a point. So this is the approximate size of their new cell. As you double the size of the cell, you increase the volume of the thing threefold, and so you wind up with this. So we already discussed a little bit about the holes in between the cells. What does it look like when you start to stack a whole bunch of these together? What's the optimum way to stack them together? What problems come up? If you wind up doing this with prismatic cells, then you wind up with some cooling issues, because you have to be able to cool the cells. Okay. Now, a couple of things happening with these new cells. In a standard wound cell, you wind up having basically this kind of jelly roll that that occurs within the battery. Well, one side of it is cathode, one side of it is anode, and in order to get the electron out and pass through there, it has to go through that entire coil, that entire spiral on the battery to get out. And that winds up building up heat. You wind up with heat stress in the battery, and so then that detracts from the cycle life of the battery itself. Well, a while back, something that really got my attention, got the attention of several others, is that Tesla has a patent for what they refer to as a tabless battery. Now, what that means is that when you do this jelly roll, you basically are leaving the top and the bottom of these rolls, the copper and aluminum sheeting that is that composes the winding of this jelly roll that composes the battery, and you wind up then having something that on the surface of it looks like, maybe you remember those old cigarette lighters, where you have a wound surface, you stick it in, and the entire surface then of that cigarette lighter gets hot. Right? So that's basically what you're going to wind up having with these new cells. The entire top of this cell is hot. It's able to pass current straight through the top of the battery, and that means that there's less heat that's drawn up through the battery and built up in the battery, because there's simply less of a distance to go, so you wind up with less resistance to get out of the battery. So that makes it so that on the surface of it you have a battery that will have an incredible discharge rate. But it's not the discharge rate I think that they're going to be talking about on Battery Investor Day. I think they're going to be talking about the damn charge rate. Because now you've increased the surface area of this battery so much that now the regenerative braking isn't going to be an issue, obviously, unless you have your batteries at or near 100%. But they're going to be able to shunt more power into the batteries that way. But the supercharging, the charge times, the thing that is the most complained about aspect of an electric vehicle. Oh, well, you know, if I drive X amount of time, I have to spend roughly a quarter of that time stopped while the vehicle is charging. And we've managed to chew that down a little bit, but it's still an issue. Well, with this new battery architecture, it's no longer going to be an issue. And that, coupled with the fact that they're going to be announcing new materials for these batteries that are simply not as susceptible to the heat. That means that the coolant loops are going to be smaller. That means that the longevity of the battery, we're going to be talking about batteries that last for 20 years. So that's the main thing that we're going to be looking at as far as Tesla's talking about their batteries, probably. Now, that's really, really important for Tesla and for anybody who's looking at Tesla as an investment for the future. What does this mean? Well, Tesla has that patent for that tabless battery. Oh, that is not inconsequential. So are they going to just sit on that and have them be the only ones that manufacture batteries? No! Elon Musk has already explained that they want to march towards a sustainable future. And the way to do that is to help everybody get their batteries. Now, Tesla, you're already starting to see these gigafactories pop up everywhere. And at most of these facilities, they're going to wind up doing some battery manufacturing, probably. Again, speculation, but I'm thinking that in the way that I'm seeing these facilities start to lay out and the size of them, some of these, it's difficult to wrap your head around just how large these facilities are. Now, that said, Tesla is going to wind up licensing a lot of this technology. Their dry electrode manufacturing technology for everybody who's making batteries in the current way, using basically a slurry to create a kind of a paint, for lack of a better term, to paint that roll that we talked about that then they roll up. Now they'll be able to apply it in a dry format and then eliminate that drying process. Be able to lay that that material down in a more even way throughout the battery, so you wind up with fewer rejected units, fewer rejected cells as you go along. All of this is absolutely huge for Tesla. So, okay, that's the basically the battery end of it, the component end of it. So then, what about the other products that Tesla? How does that relate to other things that they're doing? Well, they are trying to create a battery cell technology so that when they make the battery for the cars, let's just say that for now, that everything becomes integrated at the time of manufacture. And again, we talked about that exposed tab. Well, do you then cap each individual cell? That depends on what you're going to do with it. If you're going to sell it to somebody else who wants to make a third-party product, then yeah, that's probably what you'll do. But if you're making a big battery pack out of it for a car, you're not going to do that. What you're going to do is you're going to integrate that raw cell into the battery pack directly and skip a step in your manufacturing and just cut that portion out of it. So we're going to wind up seeing a lot of that kind of direct pack manufacturing, and what that means for recycling, I'm not really sure. Obviously, recycling all of this equipment, all of these batteries, is Tesla's goal. And so I think that what will probably happen, especially given the longevity of the battery packs that we know, how long lived they're going to be, I think they'll probably just do a prorated type of situation as far as the amount of battery capacity that's still in there, or maybe they'll be just cheap enough that you won't even care I'm kind of leaning towards the latter because, again, all of this is dependent on economies of scale that are just going to go through the roof once they start to really crank out these batteries. So that's one application. The other one, again, possibly related to that same manufacturing type, and that is their new Powerwall. Now, in the Energy Sovereignty Project, we walked you through what the Powerwall can do for you and what its limitations are. And one of its primary limitations was the fact that if you only get 1 or 2 Powerwalls, though that might suffice for your usage, especially if you have something like a small studio, very small home, or even like something like a motor home or something of that nature, where you really only do need, maybe as far as the capacity wise now, maybe only need 1 or 2 of these. The problem is that it won't be able to run all of the circuits in your small home or even your motor home once you kick the AC on. Because it only has a delivery of 5 kilowatts each one, and they stack. That was one of the primary reasons why when we designed the Energy Sovereignty Project, we thought, oh, we're going to need 4 of these. So that's what we did. We went with 6 because, again, for those of you that aren't familiar, we ran an entire home off of the batteries, and that included charging the car. And so I invite you all to go to the channel and take a look at the Energy Sovereignty Project videos. I think you'll find those really interesting. But back to Battery Investor Day and what they're going to do with the Powerwall. I've known for some time and have sat on this information that Tesla's going to be releasing a 20 kilowatt hour Powerwall. And that is going to fill the needs of the vast majority of homeowners. Now, the reason why it's important that they did it in a single unit or went to that size of a block was because you wind up having an issue with manufacturing and keeping up with demand. When we ordered 6 of those things, everybody was kind of looking at us sideways because we ordered 6. Most households require 2. That's 3 households that they can't supply just because some idiot wants 6. And we wanted 6 because of the capacity and because of the ability to release that current at an amperage that we could use to power the entire home. Well, back to the battery. What did they do? Well, now they've got the top of that all wound. You can now deliver some calculated out as much as 16 times the amount of current can now be withdrawn from the from this cell as opposed to what was able to be drawn from one of their was it the 2170 cells. So now that 20 kilowatt hour Powerwall is going to have absolutely no problem powering an entire home. It's just going to go okay then and deliver that power. So then you'll be talking about how much capacity do you really need? Most homes, even larger homes, we're running in that 80 kilowatt hour range. I had calculated out that our home would, with a car now, charging a car, would really benefit from around 90 kilowatt hours. But realistically, if you wind up having the ability to deliver that much energy, if you're able to then put more solar collection on your house, it's really, you can then go ahead and get away with now 2 Powerwalls, 40 kilowatt hours. Maybe 3 if you're, again, really maybe 2 if you have 2 electric vehicles or something like that. Because now the amount of power that this Powerwall will deliver will likely not be any kind of an issue at all. And so basically that's it as this kind of primer for going into Battery Investor Day. I expect that they're probably going to wind up hitting us with a lot of other cool stuff as well when they finally do the the reveal of everything that they've been sitting on. But we already know that now that not only is it a new battery architecture that's much larger, but also that the chemistry of the battery is far more robust than it used to be. These battery packs will wind up being able to operate at a much higher temperature and still have much less degradation than their existing offering today. With the longevity that they're going to be announcing, it's just going to change everything that we know about batteries currently forever. And I hope you found this video interesting. Please leave comments below, and as is our usual structure for these videos, what we do is we'll have a look at all of the comments after Battery Investor Day is done, and we'll start to take a look at what we got right, what we got wrong, and talk a little bit about the questions that some of you bring up about maybe where is this all going, what now is possible with this new type of battery cell, what are some of the other things that we can see doing with it. Imagine power tools from a job site that now can be charged incredibly rapidly right from your electric vehicle. And so we're going to wind up seeing vehicles with much larger batteries as far as overall capacity, again because of what I showed you about the spacing, and when you start to increase the size of those cells, the overall efficiency in usage of the amount of real estate that you have in the battery pack also increases. Excuse me. And so we're going to wind up completely replacing everything that we currently use gasoline for, all of our job site tools. We're in very short order, probably 10-15 years, we're going to wonder, what were we doing? Why didn't we start to develop this battery technology back in the 70s and 80s when we actually could have done so? The computers had just started to get fast enough that I think we could have probably pulled off maybe 85-90% of the manufacturing tricks that we're doing today. And again, if we would have started earlier, then obviously robotics for manufacturing and all of that, and computer technology would have also advanced probably at a quicker pace. And so, you know, I really kind of I have my own ideas about how much humanity has stubbed their toe on gasoline for maybe the last 40 years. Obviously, when they first started using it, it was a godsend. But really, certainly in the last 20 to 30 years, it's just turned into a terror, and it is a millstone around our necks that's been dragging us down, that now we're able to get rid of so that we can really swim in clean waters. So I hope you found this interesting. Thank you very much for tuning in. I'm apologizing for the fact that this is brief and with very little preparation, but again, my situation is that I simply am not able to get here to the studio for any great length of time. I'm in the process of debating whether or not I should move the studio over to a location where I'm at. For those, again, that have been following along, thank you for the well wishes. My mother is in hospice at the moment, and I'm her primary caregiver. And so for all of you that have had to deal with that, this is a terrible thing. Cancer is just a terrible thing, and we'll talk a little bit more about that when we return to doing the full-length videos again. And so I thank you all for your patience and sticking around. I've been watching the numbers on the channel, and most of you have hung around, so thank you very much for that. I'm very blessed to have a fantastic audience that we've built up for all of this nonsense. So again, my heart goes out to you guys as well for being so patient, and we will see you again very soon.